Chemical bonds, Module 2, Lesson 7. Okay, we're going to start off with a quick review here. The first thing to touch base on are electron shells. So recall that the atomic number of each element tells you how many protons there are in that element. In a neutral element or atom, there's just as many protons as electrons. So silicone here has 14 electrons. Now, electrons vary in the amount of energy they possess, and they occur at certain energy levels or electron shells. So the electron configuration of silicone here is 2, 8, and 4. This means that silicone has a full shell of 2, then a full shell of 8, and an outer shell of 4. Recall that each shell can hold a maximum number of electrons. Once that shell is full, electrons are bumped out to the next level. And recall that electron shells and the number of valence electrons determine how an atom behaves when it encounters other atoms. Okay, let's review the octet rule. So the octet rule states that an element will gain, lose, or share electrons to reach 8 electrons in its outer shell. This number 8 is representative of the noble gases. Those guys are stable in column 18. They all have 8 electrons in their most outer shell. Now we've got one exception here, and that exception is hydrogen. So hydrogen has 1 electron in its first shell, and the first shell only needs how many electrons to be stable, to be full? 2. 2 electrons are needed to complete the first shell. So therefore, hydrogen only requires 1 more electron to be stable. Now let's take a look at these other 3 elements. Note these guys are all non-metals. Carbon, atomic number 6, meaning 6 electrons in a neutral atom, 2 in the first shell, which leaves 4 in the outer ring. So carbon needs 4 more electrons that can either be gained or shared to reach that 8. Nitrogen, atomic number 7, 2 in the first shell, leaving 5 in the out, which means nitrogen needs 3 electrons, and it's either going to gain those somehow by taking them from another atom or share them. Keep in mind, gaining 3 is easier than losing 5. Oxygen, atomic number 8, 2 in the first shell, 6 in the outer. Therefore, it needs 2 electrons to become stable. And again, that's much easier than losing 6. Okay, we're going to look at 3 other elements here. These guys are metals. And again, the octet rule applies to these guys as well, except we're going to focus on losing electrons to reach that stable octet. So aluminum, 3 valence electrons. Therefore, it wants to lose those 3. Now sodium has 1 valence electron, so it wants to lose that to get down to the level below. So it's stable, and again, that's easier than losing 7. Magnesium, on the other hand, has 2 valence electrons. It wants to lose those 2, which is easier than gaining 6. So what I want you to do now is pause the video and fill in your notes. Go through and determine whether each element wants to lose or gain, and how many electrons it wants to lose or gain to get that full shell. Let's go through calcium together. Calcium, atomic number 20, symbol, capital C, lowercase a. How many valence electrons? Well, if I told you calcium's in column 2, right away you should say, aha, 2 valence electrons. So, looking at calcium, it's a heck of a lot easier to lose 2 electrons to get a full shell. So, the answer here would be lose, and the number would be 2. So pause the video, and when you're done, come on back here and take a look at the answers and see how you did. Hi, welcome back. So Here are my answers. Again, you might want to pause the video and check your answers. Argon, you might have found was interesting. So argon was a noble gas. It's in column 18. 8 valence electrons. It's stable. It doesn't need to lose or gain any. So hopefully you got that answer as well. Again, you might want to pause the video and just check through your answers. Okay, so this is all pretty easy, right? It's pretty straightforward. You either lose or gain to get 8. So, but why does this happen? What effect does this have in our world? Or in other words, so what? What's the point of all this? Well, the answer lies with chemical compounds and making stable chemical bonds through chemical reactions. So recall those chemical changes when we produce something new. Because recall that compounds are pure substances that are chemically combined through a chemical reaction. Compounds are composed of 2 or more different elements, and when they combine, their properties all change, just like when we looked at water and salt, NaCl. The whole reason these guys combine is to get 8 in the valence shell. Cool, eh? There are 3 types of chemical bonds. Ionic compounds, and we're going to look closely at those. They're created by the giving and taking of electrons, gaining and losing. They're composed of ions, hence ionic compound, and they're made between metals and nonmetals. The next type of chemical bond we'll look at are covalent bonds. And just like the word implies, cooperation, covalent, it's made by sharing of electrons. Covalent bonds are made of only nonmetals. And the last type of chemical bond we'll take a real quick look at are metallic compounds. These are made of elemental metals, and they create a seabed of electrons. This is why they're so conductive, thermally and electrically. Now, chemical bonds between elements are called intramolecular bonds. Ra is the key to this, intramolecular bonds. Okay, so first thing we'll look at here are ionic bonds or ionic compounds. Again, intramolecular bond occurs between the reaction of a metal and a nonmetal. Ionic bonds occur because of the giving and taking of electrons to gain that stable octet. So they make ions, hence ionic bonds. Now, once an ion's made, and we'll look at this in a bit more detail, you get a positive and a negative charge, and it's these electrostatic forces that keep these ions together, making these really strong ionic compounds. And they're, we call them crystal lattices. So you can see the negative chlorine, the positive sodium, negative, positive, negative, positive. It's that negative positive attraction that keeps it together, creating really, really strong compounds with high melting and high boiling points. Okay, so metals. Let's first take a look at metals. So metals are found on the left-hand side of the periodic table and account for most of the elements on the table. And you can see the metals here in yellow. Now, metals lose electrons to match the number of valence electrons of their nearest noble gas. So when an element loses an electron, it becomes positive because, quite simply, there's less negative charges than the positive protons. So group 1 metals, so everyone in that first column, has 1 valence electron, and as we looked before, it wants to lose it, so it has a charge of +1. Group 2, 2 valence electrons, wants to lose those 2, so therefore, charge of 2+. Group 13, 3 valence. Again, when you lose 3 negative charges, you're going to be left with 3 positive, more positive than negative. So positive ions are called cations, and you can remember this by the plus sign right in the word cation. So that T, you can remember, looks like a plus for positive. So cations are positive ions. Let's take a look at how this happens. So lithium's a neutral ion, or atom, has 1 valence electron. It wants to lose that. And when it does, it gets this electron configuration of helium, the first noble gas. Let's do the math to see how it becomes positive. So in a neutral atom of lithium, we've got 3 pluses, 3 negatives, we get this charge of 0. As soon as it loses 1 electron, you still have 3 plus, but now you only have 2 negatives, which leaves you a charge of +1. Let's take a look at magnesium. Same thing. Magnesium has 2 valence electrons. It wants to lose that. When it does, it has this configuration of neon, the next noble gas. The math? Well, 12 pluses, 12 negatives in a neutral atom leaves you with 0. As soon as you lose those 2 electrons, you only have 10 negatives, which leaves you with a +2. Let's look at the nonmetals now. Nonmetals are found on the right-hand side of the periodic table, so just this section here in green. Now, nonmetals gain electrons to match the valence electron of the nearest noble gas. Negative ions form when the number of electrons are more than the number of protons. So group 15, they have 5 valence electrons. They want to pick up 3 electrons. This makes them negative by 3. Group 16, 6 valence. They want to pick up 2 electrons, hence making them extra negative 2. Group 17, 7 valence. Therefore, pick up 1 more negative, giving them -1. Negative ions are called anions. And you can remember this by the "an" at the beginning of the word, a negative ion. Okay, so let's take a look here how fluorine becomes fluoride. So there's fluorine with its 7 valence electrons. So it wants to gain 1 electron to make 8. So there it is, stable. It now has the electron configuration of neon, 2, 8. Let's do the math. So neutral atom of fluorine, +9, -9, total charge 0. A negative ion, oh, this should be fluorine. Protons, +9. Now it's got an extra electron, so -10. We got a total charge of -1. So the ionic bond. Ionic compounds result when metals react with nonmetals. Between atoms of metals and nonmetals with very different electronegativity. So recall, electronegativity was the ability to strip away electrons from another atom. So bonds formed by the transfer of electrons. Now, when this happens, when the metals lose electrons, they become positive, and when the nonmetals gain the electron, they become negative. And it's these charged ions that are attracted to each other. So some examples are sodium chloride, calcium chloride, and potassium oxide. So here's just another picture. Sodium, 1 valence, wants to lose it. Chlorine wants to gain. So positive, negative, voila, sodium chloride. So ionic bond. Electron from sodium is transferred to chlorine. This causes a charge imbalance in each atom. The sodium becomes positive and the chlorine becomes negative. Charged particles or ions. Note, once the reaction has occurred, a new compound is made with completely new chemical and physical properties. Therefore, it needs a new name. To name an ionic compound, follow this simple pattern. First is the metal name, so that stays the same, like we have sodium. Second is the non-metal name, and we change the ending to "ide," just like we have here with chloride. So let's take a look at the reaction of a metal and a non-metal. Sodium loses, chlorine gains. The losing and gaining of electrons cause opposite charges, or ions. The oppositely charged ions are held together by strong electrostatic forces.